Foreign probiotics have proven effective for specific conditions like antibiotic-induced diarrhea, but there is little clinical evidence to support their strengths beyond that. To reach the gut, these live microbes must survive a gauntlet of stomach acid and oxygen. This hostile territory often destroys the microbes before they can establish themselves, raising serious questions about the effectiveness of paradropping foreign strains into the system. The effectiveness of a microbe is governed by its surroundings. Geography, water, and local food flora all dictate how these organisms function. Because these regional factors are unique to the subcontinent, the Indian gut genome has developed along a different path than those found in the West. Microbes don't grow in thin air. They require a specific environment to activate. A strain that thrives in one geographic context may fail to function when introduced to a body shaped by a different local diet and flora. If Western protocols are frequently neutralized by these hurdles, we must look at what indigenous interventions have adapted to survive them. True gut health is a matter of biological compatibility, matching the right microbes to the specific evolutionary and geographic environment of the host. As one of the world's oldest civilizations, India developed a variety of localized probiotics, ranging from northeastern fermented soybean to black carrot Kanji, which are now being validated for their ability to improve gut flora. One of the most significant practices is Pajaya Soru, or Niragaram. It's a simple protocol. Cooked rice is mixed with water and left to ferment overnight, then consumed the following morning. This practice was historically preserved by the working-class communities along the coastal belt of the Bay of Bengal. While it began as a practical way for those with limited resources to utilize leftover food, the overnight fermentation purposefully transformed a simple staple into a nutrient-dense morning meal. Driven by geography and economic necessity, these communities developed a complex nutritional strategy that stayed in use for centuries. To test the validity of this tradition, doctors at Government Stanley Medical College launched a multi-year project to analyze the fermentation protocol using modern clinical standards. They used MALDI-TOF mass spectrometry, a technique that identifies molecules by their mass and charge, to decode the chemical makeup of the fermented water. The researchers successfully isolated potent live strains of lactic acid bacteria, proving that the fermentation process was cultivating a robust microbial colony. They identified over 200 health-promoting postbiotic metabolites and short-chain fatty acids. These are the secondary products of fermentation that directly strengthen the cellular structures of the gut. Data from the Institute of Surgical Gastroenterology showed that the cheapest varieties of rice actually yielded the highest nutrient complexity, producing over 500 secondary metabolites. The chemical transformation during the overnight soak also works to neutralize anti-nutrients, compounds that naturally occur in grains and typically interfere with the body's ability to absorb minerals. This chart shows the dramatic shift in bioavailability. By removing those anti-nutrients, the fermentation process increases the body's iron absorption by 14 to 20 times compared to standard cooked rice. Mass spectrometry confirms that this traditional breakfast delivers a dense, chemically complex suite of micronutrients that modern clinical science is only now beginning to quantify. Beyond the chemical data, the researchers observed a profound effect in patients who consumed Pajaya Soru on an empty stomach. The 500 metabolites found in the rice water work directly on the gut cells to create a protective, anti-inflammatory barrier. This layer shields the intestinal mucosa, preventing irritation and repairing damaged tissue. Clinicians found that this barrier drastically reduced the symptoms of severe conditions, providing relief for patients suffering from ulcerative colitis, Crohn's disease, and IBS. This intervention also led to immediate improvements in basic functions, such as the efficient absorption of micronutrients and a heightened ability to combat intestinal infections. These results offer a much broader range of clinical benefits than those typically seen with narrow Western-led probiotic microprotocols. In the search for optimal gut health, the solution was never found in an imported pill. It was always present in the locally adapted ancient dietary intelligence of Indian civilization.